Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of the OpenShift Administrator's Office Hours here on OpenShift TV. I am Chris Short, Principal Technical Marketing Manager here at Red Hat, also the executive producer of this thing we call OpenShift TV, and I'm joined by the one and only Andrew Sullivan. And Andrew is going to take us on a journey through storage today, but
Indeed.
kind of the basics of storage, right? When it comes to cloud native things.
Yeah. So, as Chris mentioned, this is the OpenShift Administrator's Office Hour, which really means that we're here in the capacity of ask us anything.
Yeah.
While I do have a topic for today, I try to have one for every week and not just completely leave it to random chance. Our goal is to really help you with any questions, any problems, any issues you have, and help get those get those questions answered. So sometimes that means that we're able to answer those directly off the top of our heads. Sometimes it means that we have to take a note and go back to engineering or go back to product management and track down those answers. And we are more than happy to do that.
Yes, we will definitely do that.
So yes, today I do want to talk about storage. So storage is a topic that's near and dear to my heart. No secret, I worked for a storage vendor previously. Before that, I was both a virtualization and storage administrator as a customer.
Right.
Not just administrator, architect, lots of other hats and roles involved inside of that. So storage is something that I like and that I enjoy, and it is it's not a whole new world because Kubernetes is what 5.5 years old now.
Yep.
But it is different, and sometimes it's different in unexpected ways. So it's good to have an understanding, and good to,
Agreed.
or at least begin the exploration. I think I told you on one of these shows before that OpenShift, and really not just OpenShift, Kubernetes as a whole is it's kind of like a fractal. Right? Every time you learn something new or you answer one
Yes.
question, it spreads into a whole nother tree of more questions. And
It's
when
like
you answer one of those,
it's like a skills chart in a video game that you're trying to like add on things as you get more skills points. Yeah. It's kind of like that.
yeah, it's never ending. I don't remember which what is it, the trough of disillusionment or something like that,
Yeah, that's the Gartner thing. Yeah.
or the Dunning-Kruger effect, right? If you
Oh.
start off thinking you know what you're talking about, and then it like
Yeah.
sharply drops. Yeah, I'm still like down in the bottom of that trough every time I think I know something.
What's
it just
underneath that trough? Because that's where I am.
So yeah, it's fun. I enjoy it, as you can tell by the fact that it is quite literally my day job. So
Yeah, no, and you do a fine, fantastic job of your day job, sir.
well,
Yes.
thank you. I try not to break anything deliberately. We'll put it that way.
Well, you break things on purpose just to help our customers. So,
So as always, please feel free to ask us questions through the various chats. I believe that they're all rebroadcast to each other. So if you ask on whatever platform you are on, we should be able to see it on whichever platform we are on. So feel free to ask those at any point in time. We will get to those just as soon as we can.
Just want to remind everybody that we have a Discord channel. If you want to join us there for after the show, you can ask questions there as well.
Indeed. All right. So storage. What's the storage thing you speak
this
of?
Cloud native storage, right? Like it's a little bit different than regular storage, I hear.
All right. So I am going to share my screen here. Not because I have anything to show immediately, but because I will have things to show.
Fun.
Actually, I take that back. I do have something to show immediately. So first, when we think about storage in Kubernetes and storage in OpenShift, there's two broad categories. There is the storage that the hosts need to do the things that they need, right? And that's not just installing CoreOS or whatever operating system you're using, if it's vanilla Kubernetes. It's also, importantly, the ephemeral storage used by the containers, as well as things like container images and logs and various other things that are happening inside of there. The other set of storage is the application persistent storage. And that can come from any number of different places. And there is shall we say, varying degrees of persistence associated with that. And that can be a little confusing. And I'll talk a little bit more about that in just a moment.
Sure.
So let's start with the host storage, right? The storage that is used by the virtual or physical servers inside of your cluster.
Right.
And importantly, and Dean, I'm going to finish this thought, and then while Chris reads your question, and then we'll address it. So importantly, there is Kubernetes itself monitors the var lib partition or directory. So what is it monitoring for? So first and importantly, when we pull down an image, it gets stored underneath var lib with OpenShift var lib containers. Right. When I instantiate a pod, when that container gets instantiated, it creates a copy on write layer of that image, right? And that gets stored underneath var lib containers. If I create an empty dir, storage, not object, but declare an empty dir mount point for my pod, that gets created underneath var lib containers. So it becomes an incredibly critical and also a focal point for all of that data. Likewise, things like the container logs all get shoved underneath var lib.
Yep.
So this means that whatever storage is backing that mount, backing that folder, needs to have both the capacity as well as the performance to meet all of those needs.
That performance is important. That has bitten me before.
Exactly. And it can creep up on you very quickly and very unawares, if you will, of maybe my pods aren't doing a whole lot. Maybe everything's running along just great, and then somebody turns on debug logging for some application, and suddenly it's dumping gigabytes of log data a minute into that directory. Well, suddenly now it's going to cause a ripple, and it's going to cause potentially performance problems for other pods that are on that host because they're consuming a lot of those IOPS, a lot of that storage throughput. If it's a virtual machine, it could ripple out to other virtual machines in the environment. Hey, maybe I'm running off of 4, 8, 16 gigabit fiber channel, and this one set of pods on this one virtual machine is suddenly consuming massive amounts of storage throughputs, all the way back to the storage array. Well, that can have a lot of ripples, etc. So we do need to be aware of what's happening with those. We want to leverage all of those monitoring tools. I can't talk today. I don't. My tongue just gets in the way. All of the monitoring tools to keep an eye on those things. Okay, thought finished. So, Chris, do you have a summary?
Yeah. So our friend Dean Peterson here has a 3-node cluster. Sounds like master worker combo. One of those nodes has an NVIDIA GPU in it, or RTX 3090. I'm not sure if that matters. Having some problems getting the node feature discovery operator to work, but installed the NVIDIA GPU operator and the node feature discovery operator. I created an instance of the node feature discovery. All of the pods for each of the masters came up, but none of the nodes. So maybe it's a 6-node cluster. I'm a little confused by the question, Dean. It's a lot of words. So just it's bare metal, all bare metal. So using the assisted installer, which shouldn't matter after the fact. And so I asked if there were any taints on the nodes. None of the nodes get labeled as having a GPU. Right, because it can't find it. I'm wondering if it's because it's on the master node. Is there something going on there?
So if it's schedulable, it should allow all of those pods to be able to deploy there. What comes to mind for me, and what I'm trying to look up on my other screen here, is the HCL for the GPU operator, for the NVIDIA operator. I would think that it is. I mean, it generically says Pascal Plus. So that should include the 3000 series,
right?
Because I think Pascal was the 900 series. It's either the 900 or 1000 series.
I haven't kept up a graphic card in a long time.
I have seen some folks, not basically using desktop GPUs have issues, but I don't think it turned out to be something else, not a support or not a compatibility type of issue. It was other things.
So Dean, reiterates, or not reiterates, also states, have also noticed that the node feature discovery is seemingly stuck detecting anything. If I click on the network interfaces or disk tabs under each node, I just get a bunch of loading placeholders indefinitely. So it sounds like that operator is broken.
Yeah, it sounds like something could be wrong there. Off the top of my head, I'm not terribly familiar with the NFD
I am
operator.
curious if are there any, like, if you go to pods, like all your pods and all projects, is anything like not running or not schedulable or whatever, right? Like, it, could this be a capacity issue? Maybe, I don't know. So if everything's good and it's still not working, try removing it, deleting the namespace. The node feature discovery thing was in if it created its own special namespace, and then reinstalling it and go from there, right? That's the only thing I can think of.
And just to be clear, this is the OpenShift NFD operator, not the upstream.
That is a good question. Is this OpenShift or OKD? I don't think he said either or.
Well, the upstream node feature discovery operator.
Mhm.
So there's the upstream public one, and then there's the OpenShift one. So if we look at
OpenShift. So it is on OpenShift, and in the operator catalog or operator hub, did you use the Red Hat one? Okay, good. All right. So use the Red Hat NFD operator. Are all the you said all the pods were running, Dean? I'm curious if any other pods aren't running.
Yeah, this is one I'll have to. We can reach back into the appropriate folks on the engineering Slack and see if we can find out if there's any particular errors or issues going on there.
Everything else is running fine. Okay, cool. Yeah, that's weird. Let me plug into my node real quick and see what's going on.
And if you would like, or if you can, for those pods, for the NFD pods, if you can pull the logs and then just email them to Chris and I,
Yeah,
we'll use
that'd be the
that
best.
to get started. And Andrew.Sullivan and C-Short
C-Short,
at redhat.com.
Yeah, Dean's like, I really think it might be the master worker combo, but yeah, like that's why we want the logs. Because if that is the case, that would be a bug.
Should work.
Yeah,
it should work with the master worker combo. So if it's
right.
not, it's either a bug or there's potentially something else going on there. Would be my suspicion.
Yeah,
but
thank you.
There's no reason it shouldn't work. Yeah,
right. Like there's no reason at all it shouldn't work. From what you're saying, it sounds like everything else is working fine. So yeah, this could be a bug. So yeah, thank you. Pull the logs and let us know.
All right. So where was I? So ephemeral storage. So varlib, if we look at, so varlib is important, not just because it can affect performance. So as you fill up gigabytes, as you fill up inodes, it can also affect scheduling. So if that partition, or if that, which by default, there's only one disk in OpenShift, right? So if that disk begins to get full, essentially what you will see is the scheduler begin to remove pods, right? It will evict pods from the cluster, and or it will not schedule new pods to that node, if even though there may be CPU and RAM resources available. And I think by default, and I used to have a tab open, and silly me, I closed the wrong window, and now I haven't brought it back up yet. So I believe that by default, it will bring it back underneath the threshold of 80% utilized. So what happens when it evicts a pod, right? Essentially, it terminates the container. It means that the copy on write layer is going to go away. If there's an empty dir, right, because it's moving, right, it's going to remove that empty dir storage, etc. This is why things like deploying the registry using an empty dir is great to get up and running, but if something ever happens, then all of your container images stored on that registry instance would be lost. So keeping an eye on that, very important. It can have ramifications, both narrow and wide. If we don't size, if we don't monitor, if we don't manage that local capacity for our nodes correctly. So what are some of the things available to do that? So first and foremost, we'll rely on the good old monitoring service. And if we switch over to our node, where is it? So that is pods. That's not what I want. I want, is it cluster? Maybe. No, I think it's node. This is what happens when I prepare for a session. When I was going through all of this initially before the Thanksgiving holiday, when I took an entire week off.
Yeah, same. No, yesterday, I always say Tuesdays are my Monday because we have a heavy stream schedule on Tuesdays usually. Ooh, did it feel like a Monday yesterday? I went to bed at 8. I was done. It was just like, I'm out. Good night.
Let's see. Oops. I don't want to add another one. I want node. Come on. Scroll down for me.
There you go. Have any spaces in there? Ooh, is it really in alphabetical order or is it pseudo alphabetical order? Ah, I see where it is. Okay.
And you go away. The problem is I'm trying to do this through this interface and not through the Prometheus interface, and I'm used to the Prometheus interface.
Okay.
So what I'm trying to do is yes. Oh, that one's still going. So what I'm trying to do is show that there are Prometheus metrics that are collected that have this information, even if they don't show up in the default dashboards. And I just stood up this cluster this morning, so I haven't had an opportunity to go through and set all my normal stuff for authentication and all of that other stuff. All right, so we want to go to the console here. We want, oops, kube node status, no. I swear, it is one of these network received bytes. Nope. Anyways, I promise it's in here somewhere. I'll have to dig it up. This one doesn't show me. That's for PVs. I need to dig it up. I have somewhere in my queue, a blog post that talks about doing this and how to monitor and how to check for that local stuff. Embarrassingly, obviously, I'm not remembering how to do this after a week on PTO. So we'll refresh or rehash that once I refresh my memory.
Fair enough.
And come to that. But the crux of the problem is, and you can see down here, our file system metrics. Maybe we can go here and get a better idea. File system size bytes. Wow, that was way too friggin' hard. So this is one way that we can look at those bytes or that data. We can look at that across all of the various nodes as well. So this one you can see is just summing up all of them across all nodes. So if I go back to my Prometheus UI here, and I take this guy. I don't know why this wasn't showing up when I was trying to filter by.
Got me.
So what I'm looking for here is all of the various characteristics, right? So one of these is which particular node it is looking at. And if we look, so like here, I've got my different worker nodes. So I can sum all of those guys together and I can see how much space is being consumed on a per node basis. So if I were to do instance equals control plane -0, and I don't remember, seriously. Oh, man, I'm having, you were saying a Monday. I'm having a Monday here.
You having a Monday on a Wednesday? That's no bueno.
There we go. I swear, I do know what I'm doing occasionally.
Do you? I believe you, though.
It's dangerous.
Uh,
So we see down here, we have this endpoint. Here's SDA1, SDA2, right? We can look at all of these different endpoints and we can see, where is it? Run user. So here's var. So we can look at, for example, this particular result, and we can see precisely how much capacity is being used inside of there. We can track that over time. We can determine what's happening. However, that doesn't necessarily show, like this one is file system size bytes, right? We want to look at other things like IOPS, et cetera. So on whatever's happening. So if it's a physical server, looking at those disk metrics. If it's a virtual server, looking at both the guest OS disk metrics as well as the hypervisor disk metrics, keeping an eye on all of those things to determine whether or not, again, it's going to cause ripples. So one thing to note, I recently had this conversation with somebody internally around their customer was experiencing exactly this problem. And
Really?
they had instituted VMware's storage IO control mechanisms to basically put an IOPS limit on the virtual machines. So what's important is those IOPS limits apply to the VM as a whole. So if I have a VM that has one disk drive, one disk that is from data store A, and then I have a disk from data store B and a disk from data store C, right? Which is entirely possible, particularly when we're talking about dynamic provisioning with vSphere. Remember, it creates a VMDK that then gets attached to the virtual machine as a disk and has that, right? That's how we pass through, or how VMware passes through storage, dynamically provisioned storage to the pods. So those SIOC controls apply to the VM as a whole. So that means if I put a 100 IOP limit on one of those disks, it's effectively going to apply to the entire VM, which means that it can also affect the other pods, the other disks that are attached to there as well. It is also a sum of all of those. So for example, if I were to split off var into a separate disk, which by the way is possible, here I'll show, we go to the docs. It is documented. However, it is only documented underneath the bare metal installer. And if I go here, so create a separate var partition. So here in the documentation, and I'm going to drop that link into the chat, we can see how to drop, or how to add rather, a so Midun, I'm sure I'm butchering that. Yes, we're talking about storage.
The different kinds of storage in OpenShift land.
Exactly.
Yes. Yeah.
So let's say that I have my root disk on data store A, and I have created a second disk for var on data store B. And data store A, I want to have maybe 100 IOPS, and data store B, right, I'm going to, or the disk on data store B, I'm going to give it 1,000 IOP limit. Well, the reality is the VM, either one of those disks will be able to hit 1,100 IOPS because it is a sum of those. So it has some quirky behavior when you look at how storage IO control works. Just be aware of that. Be conscious of, and be careful ultimately, because it can lead to some unexpected.
And aware, yes.
It can, especially putting the IOPS limits with dynamically attached disks, can have some unintended consequences.
Yeah.
Note that would not apply, however, if you are using other provisioners. So for example, maybe, so you're using, you're deploying your cluster to vSphere, and you're using the pure dynamic provisioner, or the NetApp dynamic provisioner, or whatever. Those would not have the same problem applied to them, because that is, it's just network traffic as far as vSphere is concerned. Conversely, if you deploy OCS, right, OCS would be affected by that. Right, so my OCS disks would inherit or be affected by all of those same IOPS limits, and that could have, of course, far-ranging effects to my cluster. Okay, so that is var, that is the OS disk. So just to reiterate, we want to be conscious of, we want to be aware of the capacity, so gigabytes, as well as latency, as well as IOPS that are being used by that underlying disk for varlib containers, right? Because that is where all of the data for images, for copy on write layers, right? What Docker used to call graph storage, as well as for things like empty dir, that's where all of that is served from. So it is critically important to make sure that it is sized appropriately. I think we recommend a default minimum of 120 gigabytes. That may be way more than you need. That may be a lot less than you need. Again, monitoring is important.
Yeah.
So if you want some other details, there's a lot of stuff inside of the documentation here. You can see all I've done here from the root of the OpenShift documentation. There's a big storage category and understanding ephemeral storage. And this will talk about pod ephemeral storage specifically, and just making sure that that is covered. Okay, so that was type 1, right? So type 2 is application persistent storage.
There you go.
Right. So application persistent storage comes in the form of either an in-tree, or let me start before that. So application persistent storage is requested by a persistent volume claim, a PVC. And that PVC is then satisfied by, it is met by a persistent volume, a PV. So what is a persistent volume? Quite simply, it is the definition of how Kubernetes, how the nodes can connect to a piece of storage. Right? So maybe it's NFS and it simply has the NFS server and the NFS mount point inside of there. Maybe it's iSCSI. It has, the portal IP address and it has the LUN identifier. Right? Maybe it's fiber channel, same sort of thing. So the PV describes how to connect to that particular storage endpoint. The PVC is what is bound to, or the PV is bound to the PVC, and that's how the pod is associated with some storage. So how do we get that mechanism, right? How do we get persistent storage? So PVs can be created basically two ways, manually or automatically. So manually means that some poor sucker has to go in and literally define each one of those objects. Hey, my storage team gave me 50 NFS exports and 100 LUNs that are of different sizes. And so you go in and you define each one of those YAML objects, right? And if we look in the GUI here, I would be able to come to persistent volumes. I would say create persistent volume. You can see, for each one of these, I would go through and create a new, whatever this is going to be. And so we'll go this. Right, so I would be able to create this. I need to define things like the storage, the access mode, etc., and rinse and repeat for each one of my persistent volume claims. So you can automate the manual process, if you will, right? So automate the process of defining each one of these, but it's still, the PVs exist before the storage request happens, right? So I have a pool of predefined PVs. Somebody submits a persistent volume claim, a request for storage. Kubernetes looks at the pool of available storage and says, here, I'm going to match these two together. An important thing to know, you can define a storage class manually.
Yes, totally.
So yeah, storage classes don't have to be associated with dynamically provisioned persistent volumes, right? You can absolutely have a storage class that is for statically provisioned persistent volumes.
Yes.
Okay, so for these types of persistent volumes, pretty straightforward, right? Be conscious of, when we're talking about a capacity planning thing, right? Be conscious of the size of, not just the size of the application storage, right? Hey, do my applications need 5 gigs? Do they need 50 gigs? Do they need 500 gigs? But also be conscious of how much, like anything else, how much throughput, how much latency, et cetera, they're going to be expecting. This is where the storage class name becomes helpful, because you can use that to create categories of storage.
So there's a fun question in chat if you want to take that real quick.
Yeah.
Arjun, where can you real case use OpenShift? Let's see, telcos, my house, anywhere, right? Like if you want to orchestrate containers and manage containers in a way across infrastructure, OpenShift is a viable place and viable tool to do that with. but I'm
So
sure
I'll
Andrew has a better answer.
I'll just take a different approach, right? Which
Sure.
is, or I guess I'll ask a clarifying question and then answer answer one part and please clarify.
Mm.
So are you asking where would you use OpenShift, meaning Kubernetes and containers, or where would you use OpenShift compared to Kubernetes, right? So one of these is I have a containerized application. I'm deploying it to Kubernetes, right? And why would I use OpenShift instead of
Mm-hmm.
Kubernetes? The other one is why would I use containers to begin with?
Right.
So both Chris and I do officially have or technically have marketing in our titles, even though we both do very little actual marketing. Um,
Yeah,
so
that's fair.
the typical response for why OpenShift over Kubernetes is, and Chris, do you have the link for
I can.
little ebook that Joe Fernandez wrote recently?
Oh
So
no, I
so
don't.
the shortened response to that is essentially OpenShift is Kubernetes with a bunch of other things added on top, and that bunch of other things is other Kubernetes projects. So things like service mesh, things like an IDE, things like a different SDN, right? And there's now multiple options for SDNs, routers, load balancers, all this other stuff that's added in there to help make the Kubernetes experience more robust and more complete. At the core, though, it's still Kubernetes.
Mm.
If anybody remembers, we've talked about installation process on the admin hour a couple of times. Right, the first thing that happens after installing CoreOS to the cluster is we instantiate a Kubernetes cluster, and then from that vanilla Kubernetes, right, standard Kubernetes cluster, we deploy Operator Lifecycle Manager, and then we use OLM, Operator Lifecycle Manager, to deploy all of the OpenShift services. So, and I don't know if you found that link or not. I can
I
dig it up.
haven't. I'm trying. I didn't realize he put out an ebook. Like that's how out of the loop I've been. Needless
Yep.
to say, I've not gone back and looked at my email from the past week or so.
There's the
There you go.
OpenShift and
Thank you.
Kubernetes. What's the difference ebook? So if we're talking, more at the core of why use containers, why use Kubernetes, why use OpenShift, it really comes down to the application and a lot of other things. I cover a lot of virtualization stuff. So from my perspective, if you have, robust processes, if your application, if your developers, if everybody is comfortable and happy with how things work in virtual machines, maybe you don't need to go with containers. On the other hand, containers make a lot of things dramatically easier, right? All the dependencies are contained inside of there. It's easier to do things like deployment. It's easier to scale, faster to scale. Matt, thank you for chiming in there.
Yeah. We are working on the ARM bit of it, Matt, just to let you know. We see ARM just like the rest of the world does. So, but you got to remember that a lot of OpenShift is upstream components that we put together, and it's not always do all those upstream components work in ARM. So yeah. So our Junas is OpenShift, an advanced version of Kubernetes. I mean, is Kubernetes with the cloud native trail map attached to it? So if you look at the cloud native trail map, it lists like the 10 things we need. Yeah, we all want ARM. That's very true. It lists the 10
Kubernetes
things that you.
on an M1 Mac.
Yeah. Well, I haven't run any M1 Max lately, but I'm waiting for the next iteration at least in maybe a couple of years, potentially, just to make sure the ecosystem builds. But regardless,
sorry to interrupt your thought there.
You're fine. I refer to OpenShift as OpenShift plus the things on the cloud native trail map that you need to like run Kubernetes in production, right? Like that cloud native trail map mentions like CI/CD and monitoring and observability and storage and all those fun things that you would need to actually deploy applications to a Kubernetes cluster and then monitor them and maintain them and operate them in an effective manner. So that's how I look at OpenShift. And I think it's the right way to do Kubernetes, in my opinion. And that's why I work at Red Hat. So that's, my spiel.
Yeah, we're all a little biased.
Yeah, I mean, but I believe that before I worked at Red Hat, right? Like it's why I wanted to join the OpenShift team, right? So yeah.
Yeah. So I think advanced version of Kubernetes might be the wrong way to think about it. It's Kubernetes,
It's
and
Kubernetes.
it's we're not deploying a different Kubernetes,
Mm-mm.
right? So Red Hat and OpenShift. So OpenShift has the same relationship to Kubernetes that Red Hat Enterprise Linux has to quote unquote Linux, right? We use upstream components that we downstream into products, and we do a lot of testing and validation, et cetera, in order to create something that is a product and supportable by us.
Right.
So it's not an advanced version. It's not a different version of Kubernetes. It's a Kubernetes that we have tested and validated and supports. And then there's a whole bevy of other things added on top of that, as you pointed out, to make it easier for our customers to utilize. And utilize there is not just deploy applications, it's also administer, it's also manage, right? Keeping it up to date, keeping it secure, keeping it stable, etc. So still Kubernetes, just a lot of stuff around Kubernetes. And if you haven't already, I would definitely reach out to Red Hat, right? Because the account teams, right? Your Red Hat account team has some really great presentations that can talk about all of that and really go into detail there. And of course, they can always reach back into people like us to help with those conversations. But yeah, there's a lot that goes on there, and it's a huge conversation, and one that we spend or could spend many hours, just going into all of the various details there. So I was trying to find, I don't know if it's public. Like surely it's got to be on one of our public websites somewhere. But we have a slide that I always like to use to illustrate that, and I'll just quickly
Oh yeah, I
bring
know
this
which
guy
slide
up.
you're talking
Yeah,
about.
the
Yeah,
layer cake slide.
yeah. Also, Madoon, not storage related, but wants to talk more about SDN plugins in OKD4, OpenShift. Same
Okay.
thing kind of deal. If we have time.
Just
I feel
as
like,
soon as come on,
yeah,
you can
come on
present.
now. You can do a Google Slides. Come on.
There we go.
Yay.
So I like to use this slide to illustrate, all of the aspects, all of the components of OpenShift. So when you look, right, Kubernetes is this red bar kind of down
Right.
at the bottom.
Foundational layer kind of thing that we're building
Exactly.
on. Yeah.
Right. And this Linux down here at the bottom, for us, that's CoreOS, which is a variation of RHEL 8.
Right. It's designed just for hosting containers, though. Yeah.
Exactly. So this is, if you were to just go to, Kubernetes.io and click the button and get kubeadmin or kops or kubespray or pick any one of your various aspects, and you said deploy me a Kubernetes, this is effectively what you get. And from our perspective, right, the value prop of OpenShift and all that other stuff is all of the things that you see up on top of here. So on top of that standard Kubernetes, we deploy things like here, operators, right? We leverage operators for deploying and managing applications, over-the-air updates. So OpenShift is able to manage down into the operating system. So if you're familiar with VMware and vSphere, right, I use vCenter to manage and apply updates to my ESXi hosts. Well,
Can you
OpenShift
that up somehow? I
it's
don't
in
know.
presenter mode. I don't know.
I don't know.
I can do this.
Yeah, let's do that.
A comment. I don't want to
Not
comment.
Just
I want to zoom in.
Yeah, there we go.
That's maybe a little better.
A little better. I don't know. Ooh. If you did Chrome in full screen, would that help? Or Firefox, or Brave, whatever you're using. There you go. That might. Now you can zoom in a little more. Hopefully. Oh, that's too much.
I know there's no fine grained. It's Google. I can't fine grain scroll. Or Zoom rather.
Yeah.
So anyways, right? We add on all of these things, and that's effectively the value prop of OpenShift. It is Kubernetes. You can use kubectl, kubecontrol, kubectl. I like to call out all three and use all three interchangeably in order to interact with and deploy. Or you can use OpenShift, the OC command line tool, which I like because it simplifies some of the common things like switching contexts.
Yeah. Yeah, I've often used OC to help me with Kubernetes clusters because I hate changing namespace in Kubernetes.
Yeah, and it's funny because you remember I was talking with our team yesterday or the day before.
Mhm.
So the week before Thanksgiving or U.S. Thanksgiving, so 2 weeks ago, I did a demo that was vanilla Kubernetes, and it took me like 2 hours to get a Kubernetes cluster up and running because it's been a while
Wow.
since I did it, and I'm so used to OpenShift and
Right.
OpenShift install create cluster, and then I just sit
Hmm.
back and go get a cup of coffee, and about 30 minutes later, I have a cluster, and I didn't have to do anything.
Right.
So
Yeah. That's kind of what I'm used to, right? Like push button get cluster, right? I think
yeah,
Kelsey Hightower says like that's his biggest thing nowadays is right. It's not the Kubernetes setup, it's the what he's doing with it after the fact.
yeah,
That is very much where we're trying to push things, right? Like we're trying to make the Kubernetes part easier for you to
yeah,
manage and update,
yeah.
operate.
Okay, so SDN plugins. So as of OpenShift 4.6, there are two generally available, fully supported SDNs from Red Hat. So the first one is OpenShift SDN. I know, super creative name,
Mm-hmm.
literally OpenShift SDN, which is VXLAN based. It is the original OpenShift SDN,
OG.
or SDN in OpenShift,
Right.
and it's been there for a long time.
Mm-hmm.
So with 4.6, we released or we announced general availability, but it is not yet the default of OVN Kubernetes with OpenShift. So OVN Kubernetes, of course, OVN, Geneve-based tunnels, etc. So it's more modern.
Mm-hmm.
If talking with product management, discovering, well, why are we making this change, right? There's kind of two major reasons for that. So one, OpenShift SDN is effectively a Red Hat project, right? There's not a lot of community involvement. It's not used anywhere else. It's not used by anything else. So, by joining OVN and OVN Kubernetes, we now have a much bigger community and much more widespread use, which means, bugs are found faster or fixed faster, et cetera. The other one being OVN works across multiple operating systems. And this is particularly important as we draw closer to Windows containers. I almost combined Windows and containers into Winders.
Winders.
So,
That's where I'm from, how they say Windows.
So, with when we have clusters that are a mix of Linux and Windows nodes, we need an SDN that can go span across all of those nodes. And OpenShift SDN is not capable of doing that. OVN Kubernetes is. Now, those are the two from Red Hat. We have a huge partner ecosystem of additional options. So Tigera Calico, let's see, VMware NSX.
Yeah.
I'm
There's
trying to
so
think.
many CSI ones, right? Like, let me just pull up the landscape real quick. My ass.
And
there we go. Cloud native storage. There's so many of them.
yeah, so essentially we would expect
All
that most of them are going to work. Some features, so I'll pick on OpenShift virtualization. Some features want to test and validate specifically for their capability. So for example, the first version of OpenShift virtualization did not work with Calico. There was some issue with something, and now both sides have fixed it and it should work now. So just little things like that. Unfortunately, and we have this problem with SDN plugins, with CSI plugins, with others, the decision was made to not include third-party references, third-party documentation, right, et cetera, in the OpenShift documentation. So with OpenShift 3, you could go and see, here's all of my SDN options, right? Here's this list and links out to their website that says, here's how to install alongside OpenShift. With OpenShift 4, they decided not to do that, which means that, again, thank you, Matt, which means that, we rely on our partners to document, and we rely on customers to either ask or to know that, hey, I need to go and look at Tigera's website to discover if it is compatible with OpenShift. So yeah, but for better or for worse, that was the decision. And I know that the field folks they usually have a whole list of these, and I think that they often include them in their presentations to help our customers.
Yeah, I'm typing an answer to Franger Holmes thing right now. I just get some clarification.
OCS
I'll ask it. How about that? To clarify, you installed OCS. Some nodes have taints for OCS to be installed, and you can't use the normal update process without deleting pods. So that's like the overarching clarification question there, Frank. Are they just any pods that you have to delete, or are there specific pods that you're deleting? And like, what are they related to?
I'm wondering if those pods are unable to be rescheduled. Either they're failing to drain, so they're failing to terminate and be rescheduled, or which could be a resource constraint issue, right? It's unable to. That would be my question, or maybe there's some error with that OCS, particular pod where it's not terminating.
OCS notoriously does use a lot of memory, I think, so that could be part of the problem.
When is the so tomorrow at 9 a.m. Eastern is the OpenShift Container Storage Office Hour with Chris Blum.
Yes. So I will take this question and send it to Chris right now, and Chris Bloom, and we will discuss it for sure tomorrow. But Frank has clarified the taints were for OCS. I had to delete the pods from the daemon sets inside of OpenShift storage, I'm assuming is a namespace. That is weird. You have to delete pods from the daemon sets. So yeah, something's not schedulable, or like some resource constraint is happening. I feel like there, like, are new pods being created when you hit update, or just is everything just at a standstill when you hit update?
It sounds like it's failing to drain, failing to terminate.
Yeah. Weird.
So, yeah. I would definitely. So we know who to get the answer from, and that's Chris.
Yeah.
Chris, not Chris Short.
Not
Chris
just
Blum.
me. No, there's too many Chris's. We've determined. So yeah, I'll drop your exact questions in my Slack chat with Mr. Bloom, and yeah, we'll talk about it tomorrow for sure.
All right. So speaking of, and circling back to storage, and Frank, please continue to add details or ask clarifying questions if needed.
Yeah.
And I know if Chris gets a response from Chris, we'll bring that up as well. So circling back to persistent storage. So I talked about manually creating PVs. So essentially that's what we have up on the screen here, right? Defining a PV and having a pool of those available. Now, some dynamic provisioners take advantage of this. So effectively what they do is they have a storage class with a provisioner assigned to it. When I create a PVC for that storage class, the normal mechanism takes place and it says, hey, provisioner, provision some storage. And essentially what it does is in the background, that provisioner will talk to its storage device, create the volume, and then it will create a PV that looks exactly like this to map to that particular PVC request. Right. So it is a standard PV. It is just being dynamically created by that provisioner. And I can show an example of this because that's how the provisioner that I have going on in here. Chris, I don't know.
My bad.
your camera's having issues there.
Yep.
So I have inside of my lab here, I have a very simple, this is using the, it's now the deprecated method of provisioning, dynamically provisioning NFS storage. So what this does, or how this dynamic provisioner works, is it has a single NFS export that it creates folders inside of that one export to satisfy the PVC requests. So the reason why I like to use this is, one, it's super simple. It's very easy for my lab and it doesn't take a lot of resources. But I can also, so I can do like this test and say, I want to create a 5 gigabytes persistent volume claim. So there's a number of bad things about this. One, even though this says it's 5 gigabytes, it'll create a PVC that says it's 5 gigabytes. It's just an NFS mount. Or an NFS, a folder inside of an NFS export that could be, in my case, it's a 1 terabyte share, which means that if in the pod, if I were to go in and do a df-h inside of that mount, it would show up as the full 1 terabyte, not the size that I've requested here. So when I click request here, what we're going to see is a persistent claim was dynamically created to satisfy this. So if I look at my, persistent volume. So if I look at my persistent volume definition, we can see, come on, scroll down. Once we get down here, we can see the NFS server. We can see the path. So here's the folder that is on my storage host, and then it created this subfolder inside of there as my PVC mount. And then we see this claim ref. Excuse me. So this claim ref is how it is mapping that this PV was created specifically for this persistent volume claim. So we can see here claim ref, persistent volume claim, namespace default, name test 0. Right. So this prevents this PV from being claimed or being taken by some other PVC accidentally. We know it was created specifically for this one. So there's a number of, so beyond this, lab only, I would not recommend for production usage using this provisioner. There's a number of others that do or have similar behavior. So for example, NetApp Trident, this was how it worked up until version 20 or 1910, 1907, something like that, when they fully switched over to the CSI model. Effectively, it would create a volume on the ONTAP or SolidFire system, and then create a PV to map to that. So they started doing that back in Kubernetes 1.8, I think. They started very early on with that process. They're not the only ones. And that is something that is supported, right? It certainly works. However, what we're seeing and what the CNCF is doing, or more specifically, the storage SIG is doing with Kubernetes, is the in-tree volume drivers are going away. So this persistent volume claim, right, which we can see, come on, scroll down, which we can see down here is it's just a standard NFS type. This uses the n-tree volume type.
Right.
So all of these are shipped by and they're supported by Red Hat, of course. So if I come down here so I'm in the documentation, right? Understanding persistent storage. And if I scroll down on this page, and if I get down here, come on, stop jumping on me. So if I get down here,
well functioning correctly.
I know. So we have all of these volume plugins. These are all of the in-tree provisioners, with the exception of maybe that one. Right. So if I were to, if I look at and I create an iSCSI persistent volume, if I create here a Cinder volume, if I create an NFS volume, etc., right, they're going to use the in-tree drivers. So essentially, and that includes vSphere. So the default dynamic provisioner that we configure with a vSphere IPI or UPI deployment uses the in-tree provisioner. So effectively, these volume drivers have been deprecated and will be removed at some point in the future. This is not an OpenShift decision. This is not a Red Hat decision. This is a Kubernetes decision.
Kubernetes thing, yeah.
So everything is moving to CSI.
CSIs, yeah.
So CSI works a little bit differently, and it works more like Cinder if you're familiar with Cinder. And we can...
What is old is now new again.
Yeah.
Yeah.
So if we look in the documentation, again, I just went to the using CSI and configuring CSI volumes, we have this handy dandy little graphic that kind of describes what's happening. So I've taken this graphic and turned it into a little thing here that describes the process of dynamic provisioning storage with CSI. So essentially it works kind of the same way, right? I request a PVC, I create a PVC, and now my external provisioner has, right, that controller sees, hey, a new PVC was requested. It then talks to the underlying driver container. Now, most of this is probably going to be the same as it was with, right, previous iterations. The difference really comes in how it is creating those volumes, right? Or excuse me, how it is defining those volumes into OpenShift, into Kubernetes, and how those are being mounted. And especially the mounted part is important. So with an in-tree, right, all of those drivers are effectively expected to be a part of kubelet or accessible to kubelet directly. With CSI, the CSI provider, so NetApp or Pure Storage or Dell EMC or OCS, so the CSI provider has pods that are deployed to the host. And those pods have the logic for mounting those volumes. So just to step back, let's look at an example. So if I'm mounting an NFS export with the N tree, essentially it's reaching out to the OS and saying mount -t NFS, blah, 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 blah. With CSI, it doesn't really know or care what the protocol is. It's just saying CSI provisioner, CSI driver, mount this volume and tell me when it's ready. And that's as much as Kubernetes is aware of. So I see a little bit of chat going by. I'm just going to.
So if a PV is full, a PVC is full, does it, and you need, more storage, ran out of disk or whatever, will it sit there in a pending state or will it fail immediately? If you're provisioning it and it's full, you're gonna get a failure.
So if the backend ran out of capacity, will the PVC wait in a pending state? So I would expect it to sit in a pending state, but it would also depend on the CSI provisioner and what action it takes. Some of them will,
and I believe you can change the behavior too if you want, right? For most of them.
Yeah, I would expect that. I would expect that most of them, the PVC will sit in a pending state, but you would be able to look at the provisioner logs and see that it is unable to provision because of X.
Right.
So it would be, the PVC would be unbound effectively, and it would start saying that it's failing to provision, and that would be surfaced up depending on the driver, both in the PVC, but potentially in the CSI provisioner logs.
So I have a question.
Okay.
CSIs for local storage. Would that even exist?
Yeah. So, the storage SIG and Kubernetes, upstream Kubernetes, with in-tree drivers going away, effectively everything has to switch to CSI.
Right.
And that would include any of the local storage stuff. So if you're connecting to a local one, et cetera. In the future, everything will be CSI or a CSI type of model and not the in-tree. What that timeline is, I don't know. I used to hear Kubernetes 1.21, 1.22 timeframe. I don't know if that's changed because it's been like a solid 12 months since the last time I checked.
I would assume it's been kicked because the big thing this release is that Docker is being deprecated, which we're switching to Containerd in Kubernetes, and that's freaking everybody out. That has been the discussion of the day in the ambassador channel for CNCF. So yeah.
That's exciting.
Yeah, I mean, it is exciting. It's also, it shows where some knowledge and messaging gaps are. There's a lot of confusion, it seems. Wait, I thought Docker was Kubernetes or vice versa. I thought Kubernetes was Docker. No, it's a container orchestrator.
Yeah.
There's multiple kinds of containers. Look at OCI. There's, Kubernetes runs any OCI compliant container. There's lots of them.
Yeah. So I know we've only got like 2 minutes left. So I'll close out by saying that much like the SDN plugins, CSI provisioners, most of them come from third parties. So you need to check with your storage vendor on support with OpenShift. For example, I've said Pure and NetApp and Dell EMC, IBM, Hitachi, Fujitsu, right? They all have CSI provisioners that work with OpenShift. You'll notice a couple of others in this list. In particular, you'll notice Manila CSI and the Overt CSI driver. Both of these come from Red Hat, right? So the Rev team created and manages this Overt CSI driver. It's deployed by default when you do a IPI deployment on Rev. So those are supported by Red Hat. The others would be supported by our partners. There's one other thing I was going to say that has completely slipped my mind, so it must not have been important. There's Peter. So Peter's saying CSI can handle local stuff. So Peter's one of our product managers who helps with the.
Yeah, I mean, I know it can, but we definitely need to make that easier for folks, I feel like. But we got to go. I got another show
Indeed.
to produce. So thank you, everybody, for joining. Check us out next week. Same bat channel, same bat time.
Next
or
week,
not next week.
I have a prior engagement, one that predates this show even. So
Wow.
next week we will not have a show. The week after we will have a show.
Cool.
If you have any questions, any concerns, any etc., please feel free to reach out to Andrew.Sullivan at Red Hat or C-Short at Red Hat, or on social media, Practical Andrew on Twitter and C-Short, right?
Chris Short. You'll get it
Chris
right
Short
eventually.
on Twitter. No, I won't. Let's be honest. At this point, if I haven't gotten it. So thank you, everybody. Appreciate you tuning in. Thank you to all the people who have asked questions, and please don't hesitate to reach out.
Thank you all. Have a good one.